Hello viewers, welcome to our channel. Today we are beginning with the new module for our unit of thermodynamics. I am Dr. Archana Chaube from the Department of Chemistry, Bhopal School of Social Sciences. In today's lecture, we will be dealing with the first law of thermodynamics. So let us begin. The topics that we will cover today are: what is the meaning of state variables, the meaning for extensive and intensive properties, the statement and understanding of first law of thermodynamics, and the relationship between internal energy, heat and work. And in the end, we will understand about the concept of system and surrounding and its type. As we have said, state variables. What are state variables? There are two types of variables: state components or state variables and path variables. So, state variables are those which do not depend on the process or the path by which the process have been completed. Its value basically depends on the initial and the final state of the process. Therefore, they are termed as state variables. They depend on the state of the matter, whereas path variables are those whose value will keep on changing according to the path that has been followed to reach from the initial state towards the final position. As we can see over here, like for example, in any system, the value of heat or the value of work, internal energy, these are all state variables, because if we start from a point A and reach to the point B or 1 and 2, whatever we say, the paths can be various. As it is shown over here, it can follow a path which is represented by the blue line, a path which is represented by the red line or the green line. Each path to reach from the initial to the final state may be different, but the value which we will finally obtain for these variables, that is internal energy, heat, work, their values will remain the same. And if we talk about the change in internal energy, the value of change in internal energy is basically the difference of its value at the initial state and the final state. So, these macroscopic properties which are used in thermodynamics, or these variables are used to describe the condition of the system, like for example pressure, temperature, volume are few which we can consider. Now, as I have said, thermodynamic state variables. The thermodynamic state variables are macroscopic quantities that determine the system's thermodynamic equilibrium state. A system which is not in equilibrium cannot be described by state variables, and state variables, as we have said, can further be classified into two categories: intensive and extensive variables. So, intensive variables are those variables which are independent of the dimensions of the system, like the examples are pressure and temperature, while extensive variables or extensive properties also, as we say, are those which depend on the dimension or the size or the matter of the system, and they are, since they are depending on the matter, therefore volume, mass are such properties which are considered as extensive variables. And point to remember is, all the properties which are related to energy comes under the category of extensive variables. Here we can see various examples. The definition again I have quoted over here: intensive properties depend on the amount of the matter which is present, and extensive are which actually its value will depend on how much the matter is present. So, there are number of properties shown over here. Example of intensive properties are the mass, length, entropy, and extensive are the ones which are not depending on the mass. Now, coming to the law which governs the thermodynamics in terms of energy, it is termed as the first law of thermodynamics. Before we get into the first law of thermodynamics, we need to understand the relationship between heat, work and internal energy. Just like mass, energy is always conserved. It means it can neither be created nor it can be destroyed. Internal energy is also a thermodynamic property of the system, and it refers to the energy which is associated with the molecule of the system, and it basically includes the two major type of energy. That is, we may say that internal energy, which is represented by capital U, is actually a summation of the kinetic energy of the system as well as the potential energy of the system. So, whenever a system it goes through any change due to interaction, and there is an interaction and a change of heat and work and internal energy, it is followed by numerous energy transfers and conversions. And however, since we are saying that there are transfers and conversions are occurring, but overall there is no net change in energy, since we have just now quoted that as mass cannot be created nor destroyed, same is the condition of energy, it is always conserved. Therefore, the first law of thermodynamics is also termed by a name which is known as law of conservation of energy. And if we go to the statement of the first law of thermodynamics, it states that heat is a form of energy and thermodynamic processes are therefore subject to principle of conservation of energy, which means that it cannot be created nor destroyed. It can, however, be transferred or transformed from one form or one location into another and converted into one form to another form of the energy. Similarly, if we look, just now we have discussed the first law of thermodynamics, it also affirms that the heat is a form of energy, therefore, it is changing when we heat a particular object, it gains the energy, but we have not created that heat, it was already existing, it is just moving from one place to another. So, it affirms that heat is a form of energy, and also the thermodynamic processes, since they are governed by the principle of conservation of energy, the first law, as I have already termed, is also termed as the law of conservation of energy. Now, as we can see over here, this is a system where we are showing that a piston is attached to a cylinder which is filled with gas, and when pressure is applied, the piston moves down. That means a work is being done, and since there are molecules, they start coming, they are far apart over here in the first condition, whereas in the second they start coming closer to each other. So, when they come close to each other, there is some transfer of heat as well as there is a work which is done by the system. So, a thermodynamic system, when it is in equilibrium state, it possesses the state variables which we have just now discussed, the internal energy, and between two systems like this over here, the change in internal energy is depicted by the difference which is equal to the difference in the work done by the system and the heat transferred between the system. So, we may say that what is the change in internal energy, it can be referred as capital E or capital U. So, capital E, either you can write capital E or capital U, both are used for internal energy. So, what is the meaning of change in internal energy? It is actually the difference in the amount of heat transferred and the work which is done for that transfer of heat by the system. Therefore, the first law of thermodynamics states that energy of the universe remains the same, though it may be exchanged between the system and the surrounding. As the two terms have come just now, system and surrounding, we will be seeing further in our presentation what are the meaning of system and surrounding. So, we are saying that there is just an exchange which keeps on occurring throughout the universe, and this universe is also governed by the first law of thermodynamics. So, now as I have said that the first law, it tells us about the relationship between internal energy, heat absorbed and work done. These are three important state variables which are related by the first law. Now, the term system and surrounding, what do we mean by this? As this simple example of a cup filled with tea. So, this cup, it has a boundary, because we know that we are filling tea inside the space or the volume which is holding this. this is the place where the tea is filled, and since this cup has a specific shape, that sides of the cup are meant as its boundaries. So, by this boundary, this is one system which is acting as a part of the holding capacity of this cup where the tea is filled. So, this part is one system, and there may be outside is air, air is another system. So, the two are separated by this boundary. So, the surrounding around the system are the two things. The system is tea which is filled inside the cup, and surrounding is the air around. And how are the two separated? By the solid structure of the cup, because it has a specific shape, which means system and surrounding are separated by specific boundaries. All those things which can be separated by boundaries, then only we can demark this is a system and the other one surrounding it is termed as surrounding. Now, taking examples of thermodynamic systems, they can be classified into three types: open system, closed system and isolated system. Open system, as the name itself suggests, as we have seen that we were talking about a system where there is matter, where there is energy, where there is heat. So, if I am saying it is an open system, so there is an exchange of both matter between the system and the surrounding, there is an exchange of heat between the two. When this is occurring, that means our particular system is open for the exchange of both the things, matter as well as energy or heat. So, it is an example of open system. A closed system is one in which there is exchange of heat possible, but there is no exchange of matter between the system and the surrounding. Whereas an isolated system is one where there is, the term isolate means away from everything. So, isolated system means a system in which there is no exchange between either heat or energy as well as matter. If we talk about these three conditions in our day-to-day life, so this is an example of open system, closed system and isolated. Open system is a vessel in which something is cooking and boiling, and when we are cooking it, obviously vaporization is occurring. Heat is also coming out, and in form of vapors the matter is also open because it is not covered. So, it is an open system where exchange of matter and energy both is occurring with the surrounding. Whereas, a closed system is a vessel which is covered with a lid. So, when we cook and when we cover it with a lid, the vapors are not allowed to escape, but obviously you are heating it on a burner and the vessel is taking that heat, then only the food is being cooked. So, there is an exchange of heat which is taking place. So, heat is being exchanged, but matter is not able to escape out. So, this is an example of closed system. And the third example of isolated system is the thermal flask in which we carry our hot pots, in which we carry our hot tea or coffee. So, we close it and we fill it till the brim and we close the lid. So, even if we open it after hours, we find that it is still hot and steaming because neither the heat is able to escape nor the matter. So, such examples are those of the isolated system. Okay. So, now let us see the conditions in various changes that will occur and what will be the values of internal energy, heat and work. Now, if I take three conditions, the change in internal energy, if it has a positive value, that means the internal energy, if it will increase, it will only occur when there will be entrance of heat that is occurring. So, if internal energy will increase, that means I am giving heat to the system, and when I am giving heat to the system, like for example, I take a piston filled with gas, a cylinder, and this is the piston, and apply pressure from top. So, the piston will move down, and doing this, what is happening? The gas molecules which were filled over here, they get compressed in a small space, and due to which the heat of the system is increasing, and though the internal energy of the system is also increasing. Now, if I take the condition that the value of internal energy is negative, which means the value is decreasing. So, when this will occur? When the heat which is in the system, it is decreasing, and when the system is, if heat is decreasing, that means I cannot take the heat away directly. It is the condition when in the same example of a cylinder which is connected to a piston and gas is filled, now the piston is moving in the reverse direction. It moves upwards, and we know that a gas, when it is compressed, the energy molecules come closer and the temperature rises, whereas on expansion the gas always cools. So, here expansion is occurring, and on expansion what is happening? The gas is cooling, and due to which internal energy is decreasing, whereas when we are compressing it, the internal energy is increasing, which is represented by the positive and the negative signs respectively. And if I am saying that the change in internal energy has the value 0, that means none of the action has occurred, neither expansion nor contraction. So, because we know that first law has already said the relationship of internal energy is the difference of heat and work. So, when there is no heat exchange and no work done, then only the value of internal energy will be equal to 0. That means no work has been done and no change of exchange of heat or energy has occurred. So, this is what we have discussed about the first law of thermodynamics, its statement, its relationship in our day-to-day life, the concept of surrounding, system, state variables, the intensive and the extensive variables, and the meaning of internal energy, its relationship between work and heat. So, now in the next module, we will continue with the second law of thermodynamics. I hope you must have understood this topic. Thank you.